Hello, welcome back. Trying to now get back to the homework problem. So, homework one, problem number two, guys. Homework number one, problem two. Not the same problem, but kind of similar to the problem that I given you on the homework. So, let's say we have output CFS divided by some reference input. I call it RFS. So, whenever you do output over input, remember, if you recall, what did we call that? We call that a transfer function. So let's put it in there. Transfer function. All right. So this is called the transfer function now. Okay. So don't forget about this. Output over input is always called a transfer function in this case. Okay. So let's say we make up a transfer function 8 over s squared plus 6s plus 2. This problem is kind of similar to the homework problem. Now this is in S domain or the frequency domain, and from this we would like to write a differential equation. Differential equation is that guy expressed in the time domain. Okay, so let's write that differential equation for this. Pretty interesting. Okay, so how do we do that? Well, first of all, let's cross multiply. So this guy goes here, this guy goes over there. So now you will have s squared plus 6s plus 2 times the CFS. Okay, that's not that bad, is it? So this goes on the right hand side, this becomes 8 times RFS. Well, you recall that the table that we did, now we can use that table. The table we talked about, the inverse Laplace transform. Inverse means that you are going to convert that frequency domain into the time domain to get that differential equation. So this is called the inverse Laplace transformation. Laplace transform. So we are going to take the inverse Laplace transform of this transfer function that we had. We cross multiplied, we got that. So I could literally write it like this: CFS plus 6 times the S times the CFS plus 2 times the CFS equals to 8 times RFS. Well, in the next step, we are going to use the symbol of inverse Laplace transform. So do this and then put an inverse sign on it, okay? So here we go. So this is the inverse Laplace transform of s squared CFS plus 6 times the inverse Laplace of s times CFS plus 2 inverse Laplace transform of CFS, and 8 times the inverse Laplace transform of RFS. So instead of writing t, just to be consistent with the book here, I am just going to write this as 8 little r and 2 times c little c. So this s squared, if you recall, this is the second derivative now. So d squared of c dt squared plus 6 dc over dt, just replacing that with the differential equation from the table, if you recall that table, remember. And then over here, this will be 2c is equal to 8r. So this is indeed the solution to this problem. Let me remove the screen just a little bit up so that we can write it a little bit more clear for you. So here the solution or the answer to converting that transfer function into the differential equation now. So this is called the differential equation. So that's called, it's not pretty scary word, but not really, differential equation. That's what they call it. It's in time domain now. So differential equation. Remember, we're not solving any differential equations. we are solving usually in converting time to frequency. In this case, we are getting the frequency back to the time domain, and hence our answer is going to be dc squared dt squared second derivative plus 6 dc over dt plus 2c is equal to 8r, and that is the solution to your homework problem 2. So similar problem, homework 1, problem 2, and this is part A. So similarly you can do part B, and I will see you in the next video trying to do that problem 1 for you now. Okay, thank you.